Hello, my friend. Yo, what's up, Kaizen? Wait, I said Kaizen, I'm wildin'. Krim. Yeah, I just solved this problem. We looked at like O of 1 solution. Try to figure this out. S2 is empty. We just empty everything from S1, 1 to S2. Just return the top. So interesting. Did like 1, 2, 3. You push everything to Q2, S2, so it'll be 3, 2, top and then peak. Okay. It's a problem name. It's called implement a queue using stacks. LeetCode 232. I just finished solving it though. I'm just looking at the more efficient solution. I want to do that hard problem next. So here's the second stack in reverse order. And down so you can just pop out here. So if I said pop, if not, I just do top side too. So I just get the top and I can pop this off. But then, like, let's say I push something else, like a 4. Oh, because it's a queue, so all these actually has to get emptied out first. Yeah, because if you do pop, you would just do like pop 1, pop 2, pop 3, and then once. How do things get emptied out of stack 1? As soon as you reversed, all these would have been gone. Damn, that's actually a really genius solution. I don't know, Krim, you should check this out. With 2 stacks, you're able to get O of 1 for initialization, O of 1 for push and peak, and O of 1 for the time. Pop, peak, push, and empty. It's amazing. Add O of N solution, but I'll take it. Let's do maximum frequency stack. Design a stack-like data structure to push elements to the top of the stack and pop the most frequent element of the stack. Construct an empty frequency stack. It is. Wait, which one? This one right here, or that 2 stack problem? Probably this one because it's LeetCode hard. It's a stack like data structure, so I'm guessing you don't actually have to use a stack. So essentially, we want to be able to push things onto the stack, and then when they pop, you pop the first occurrence of the most frequent element. So to me, this says we need some type of counter. The 2 stack one. Yeah, that was actually like I know I said LeetCode easy, but I think that's more of a medium problem. Like that was a pretty good one. I think I had a pretty good solution. It's pretty, even though it's O of N, it's still like, I guess since I'm using C++. What the fuck? Yo, is that a glitch? It just says I did -% runtime. What? I don't even know what that means. I gotta screenshot that. Random glitch on leetcode. That's weird. Let me send that to myself. -% runtime is insane. It did not do that before, I swear. Anyway, let's get back to the problem. Probably gonna have to whip out XCali draw for this shit. Yeah, for real. My code was so cooked that it broke leetcode. Let me just copy this. So we want a stack like data structure. It's able to push elements on. So, like, let's say push 5 onto the stack. So it'll be 5, 7, 5, 7, 4, 5. Mm-hmm. And then when they pop, since 5 has 3 occurrences, it would remove the 5. Return 5 is the most frequent element. Stack becomes 575. 5775, 74, because you'd pop this off. So it looks like we're removing from the middle of the array. So I think we're gonna have to use a vector. And we're gonna have to have, I think we're gonna have to have some type of counter. So let's say like count, and I guess the key will be what element and then the frequency. So let's just see what would happen here. If this is too small, I could like reformat it, make it like bigger. I don't know, let me know. All right, so we have count, and I'm guessing so they pushed on a 5. So we go 5, would have 1 occurrence. Yo, software, what's good, man? Yo, I found out a project I want to make in C++. I want to do a process a process manager. So you know, like when you run, like HTOP, where it like tells everything about your computer, like what process they're running, the process ID, how much RAM and stuff it's taking. I want to make one of those. All right, and then they push 7, so 7 should have a 1 as well. It pushed 5, so this just goes up to 2. You never heard of process ID? Process ID. What the hell? HTOP? Like something like this, like HTOP. Like kind of it tells you like everything that you're running, the process ID, the user that's running it. I feel like this would be hella cool to make. I don't know if we could do it. It might be like over my skill level, but or we can make a string class. Can we do that? Make custom string class, something like that. I want a cool project to do. But I want it to be more simple than HTOP. But that's the motivation. Yeah, kind of like a task manager. Yeah, yeah, yeah. Pretty much. All right, so we push 7. We push 5. And then we push 7. So no, 7 has 2. We push 4. So like 4 has 1. When we push 5, 5 has 3. When we pop, custom string class would be more of a learning experience in C because you'd have to learn dynamic memory allocation. Oh, let's do that then. I think that sounds easier than that process thing. Maybe we could do the process one later. That was super cool as you taught me about that bat file and like the source and the headers. That was pretty fun. All right, here's the problem, guys. If we have a counter like this, when they pop, how are we supposed to know which one has the highest count unless we count? I think our counter should work a little differently. What if our counter had the number of elements? C is amazing. Wait, but C++ is like C. We don't actually have to like. I don't have to actually download C, right? We can just like use C++. So I say we pushed on. Let's say we might need a max to know what the max count is. All right, let's say we had max, right? Right, no, max count is gonna be like 0. Our count, we're gonna push 5. So 5. So our max will go up +1. So our max is 1 now. And so that means we're gonna put a 1 because we have an element that has 1. And this is gonna be a list. We're gonna have 5. The MSVC compiler comes with C. You just need to rename your file. Oh, am I using MSVC? I thought I was using MinGW or G++. Oh, I was playing with this thing. I was like printing out memory addresses. I don't know, software. Can you explain to me, like, if you have a string and you print out, like, if you have a pointer to the first element in the string and you print out that, it'll print out the whole word. It's kind of crazy. G plus comes with C too. Oh, nice. I think it was pretty cool when I was printing out these memory addresses. Like IP is the integer pointer, so it points to like the 1. The array is also a wait, no. Yeah, IP is that. To main.c. Oh, that's nice. I got distracted. All right, let's get back to work. So we put 5. Let's say we push 7. Our max is at okay. Our max is at 1. How are we supposed to know, dude? I think we might need 2 counters. Like one till we put like what the max count is. All right, let me just see if this works. So let's say there's another count, right? And there's like a 5, and there's 1 5, and then there's a 7, and there's 1 7. So we add the 7. We say, hey, how many 7s are in our count? There's 1. So we add that to the list of elements that have 1 occurrence. It's like a 7 here. We had a 5. 5 we check, it says 1 occurrence. So we're doing 1 plus 1 is 2. Is that greater than max? It is. So we move up max to 2. And now we need a new key. So 2 is just going to have 5 in it. 7 again. We check the 7. Wait, no, so this should be 2. We check the 7. It has 1 occurrence. 1 plus 1 is 2. Our max is already 2, so we don't change it. And we're just going to put the 5 and the 7 inside the 2 counter. Next is 4. We don't have any 4s. We just add that to our regular count. So like 1. And then we add the 4 here because it's 1. Next, we push a 5. Pretty much same story. The count of 5 is at 2. 2 plus 1 is 3. So this goes up to 3. Our max count goes up to 3. And then We need a new key. So we do 3. There's gonna be a 5. So now when they pop, wait, is this it? I think so. Yeah, I did 4, 5. Okay. So when they pop, here's what we do. We see our max count is at 3. So we go, hey, query the list counter at key 3 and pop off an element and return that. So 5, we'd return 5, right? And this is now empty. And we decrease our max count. Wait, no. Once this is empty, we decrease our max count. So our max count goes back to 2 now, right? They pop again. So now we know our max count is 2. We just go to the set. Bro, this is it. That's the answer. Yo, Karim, bro. Yo, come on. This makes sense, right? You see any problems with this? Because if the max count goes down to 2, we'd pop off the 7, and that's exactly what we want right here. I think we're cooking. Counter for like, so key is gonna be the counter with the like the element and then the frequency. Next we need another counter. I'm gonna call it a list counter. It's just gonna have a number of, it's gonna be an integer. Int, and that just represents the number of, yeah, just an int, that's fine. The other key is really gonna be the descriptive one. List of elements that have a frequency of int. We need a max. Max frequency, maybe? At least max freak. To store the max amount of the max frequency. That's really it. I think that's all we need for there. All right. So when we push, let's go back to our drawing. When we push, we add it to our counter with the occurrence, and then we get that number that we got from the counter, and then add it to our list counter and increase max. I think that's how that works. Add 1 to the oof. I'm supposed to get my break right now. I think we'll take a break after this. I'm kind of cooking right now. I'm gonna go for another 20. Add 1 to the current frequency. Check if that frequency, I'm just gonna put freak, is greater than max. Now, append that value to the freak counter. Yeah, I think that's. I'm sure it's not super descriptive, but I'm sure I understand what that means when I get there. So we add it to the frequency counter. I think that's literally it. Yeah, we add it to the regular. We add one to the current frequency. Check if that current frequency exceeds our max. I guess maybe like if so, max freak plus plus. And then append that value to frequency counter. Okay, pop is where it gets interesting. So when we pop, we gotta say query max frequency. You should solve it. Solve it. It's called max frequency stack. You should yeah, go. I'll open up leetcode. You should go for it. Let me see your solution. Query. So query max frequency. I lost my train of thought. What was I writing? Query max frequency. So we want to pop something. The max frequency. Oh yeah, in this counter. Pop off an element if the list is empty. Max decrease max frequency. If it's empty, decrease in max frequency. I think that's literally it, right? I think there's nothing missing, right? I surely hope not. Okay. Does C++ have a counter? Is that a thing? I don't think so. Trim, if you know if C++ has a counter, let me know. If not, I'm just going to make my own counter. Ordered map of ints. Unordered. What's a counter? You know how like you want to know like a frequency of something. So there's like if there's one of them, the key will be the number you're looking up, and then the value will be the occurrences of it. In Python, we have something called counter, and it just does it automatically. I think you have to manually do it here with the hash map. Yeah, it's like a Python thing, but it does the counting for you. Like in Python, I could just do this counter and then like put in a list in there and it would just out and then have this equal something. So like count equals like that would be Python. And this counter would be like a counter object that has all the frequencies. But It's not that big a deal. So we have our unordered map. Now we need our list counter, which is pretty much the same thing, except we're going to use a vector. Yeah, I figured. Python gives you like cheat codes. And so it's going to be a vector of ints and freak. Int mass freak equals 0. So if they want to push, we say counter. Well, oh damn, I forgot. Can these function? Can these like functions see stuff that's inside of here, or do I have to put it outside in the public? I kind of forgot. Let me know. Counter about plus plus. Counter at val is greater than frequency. If it's greater than, we just say max. It has to be outside. So what's the point of this? What is this thing even for? Like, what would I ever do there? It seemed like every time I have problems like this, I just leave this shit empty. I don't think I even have to have this if statement. I think I can just use max. It's like max frequency equals the max of counter at val and max frequency. So I should update our max frequency so it always has the biggest number. Yeah, it's fine. And then we append the number to value, so what did I call it? List counter or something? I call them both counter like an asshole. Let's call it list counter. List counter at val? No, at counter at val. So it'll give us the frequency. Dot push back val. That looks perfect. This is lovely. So list counter, and then we get the frequency of the current element, and then we push it back to the vector that has all those elements to have that occurrence, that frequency. This is elegant. Pop. Where max frequency in the list counter? Okay, yeah. The thing I'm gonna pop off would be a list counter at max frequency. Dot pop. No, no, no. I think it's called pop back or something. But is there ever a way this could be empty? Because I don't want to pop an empty. It shouldn't be. I don't think it should be. So we need to return this. So int res is going to be list counter at max frequency dot back. Then, of course, we pop it off because it's supposed to be gone. Yep, yep, yep. So after we pop, we have to query to see if it's empty or not. So if list counter at max frequency dot empty, then max freak minus minus. That makes sense. And just return res. I think this makes sense. Let's double check, boys. All right. We gotta order map our counter. I order map that's an int of int is the key. Value is the vector of ints. List counter. Max frequency starts off at 0. If you push on, we say counter at the value dot plus plus. Max frequency is always going to be the max, so we have to compare to see if it went above our current max. Append the value of the max frequency to the counter. So list counter at, and this will be a counter, like the frequency, and we push back the val. This is lovely. Pop, we need to get the element at the max frequency vector. So we say we assign it to a res, and we use back to get the last element. And since we're popping, we need to remove it. So we use the same thing and we pop it off. And if it's empty, this is lovely. Come on, first try. Fuck. What did I do? I forgot a colon, didn't I? Okay, that's fine. Oh, pop, you can't do that. Okay, then what's up with this pop back stuff? Why isn't it? Can't you just use pop? Is there like a pop front or something? I'm not a big fan. Not a big fan. Holy shit! First try. I count that. Oh no, I got it wrong. What happened here? So close. It mixed up the 2 and the 1. I must be doing something a little silly. So you went. What happened here? We went. Let's say we had like. It went push 1 1 1 2. So 1 would have an occurrence of 3. For our list counter, it would literally have 1, 2, and 3, all with 1s in them. Okay. Push, push, push. And then we push a 2. So there'd be a 2 that has occurrence of 1. It has a 1. It would just push it back here. So this would be 2. Now we pop. We go pop, pop. I should have got 2 1s apparently. Oh, what's our max frequency? Our max frequency should be 3. I think no, this actually worked. We got the 1-1. So we go to our 3. We pop off the 1. So this is empty. Max frequency should go down. We return the 1. They pop again. We check the 2. 2 has something. We pop it off. So both of these are empty. It should go down to 1. Okay. We pop up and then we push 2-2-1. 2-2-1. Okay. Did my mouse just die? Come on, bro. Stop the malarkey. Another- Okay, my mouse froze. DPI is so stupid. Then now we push, 2-2-1. So 2 is going to up to 2. Max goes up to 2. Do another 2. So 2 goes up to 3. Max goes up to 3. All right, here's where it gets interesting. We go pop, pop, pop. 3 pops in a row. We outputted 1-2-2. We should have got 2-1-2. So what happened here? Oh, I forgot. 2 would have had a 2 and a 3. Okay. For some reason, we got a 1. I think this means that our... Yeah, for some reason, I got a 1 right here. After we just pushed on 2 2s. So I think it's in our push function. Counter at val plus plus. Max and freak, it was the maximum of counter at val. Max freak. Okay. So max freak should have went up to 3. If list counter at max freak is empty and max freak goes down 1. So we do... What's happening here? We pop, it should have got a 2. It should have got a 2. Not a 1. 1 would indicate that... Am I not decreasing? When I pop off, it must not be decreasing. Is this not working? So silly. As soon as we pushed on 1-1-1 and we popped off 2, it should have removed this and this one, and max frequency should have went down to 1. Oh my god. Get a hint. See it. Your logic is very strong. You correctly identified the need for. Okay. Take a closer look at your pop logic. What happens to the counter map the individual frequency of the element after you move an item? Oh. Oh. That makes sense. Count. I knew it was something stupid. My scuff solution just passed. Oh shit, nice. I think I'm right behind you. Yo, send over your. Can you send it? I want to see what you wrote. Something. So count. It's just counter at res minus. I think this is it. Yep, we got it right. Yeah, it was one little error. My logic was correct though. I count that. That was pretty good. I never had to use like a regular map. Always an unordered map. Was it fast? How fast was it? Let me copy this over. I need my credit. I need my credit. Nice. Simplify path. I feel like yo, did we lose software? Is he gone? Either way, yours is faster. Oh, all right, I'm taking my 10-minute break. We just went kind of crazy. That was fun. Yo, we're low key eating, bro. We're going crazy on leetcode. I'm gonna use yeah, map is slow. I think it's like login. Is there any good problems you've seen that's like decent to solve? Like he's gonna hit me with this. It's gonna be so annoying. I'm not castling, bro. I'm simply not. Oh my god. I'm getting fried so hard. Man, fuck this game. Swear to God. I cannot play that fast. I'm on a 4-game losing streak. Do you like graph problems? What's your favorite data structure? Like what's your like bread and butter? I don't know what to do. Graph algorithms? Yeah. Graphs are pretty cool. Good old, good old. This guy just lost his queen. It's pretty wild, my friend. It's pretty wild. I need to get better at the like MST. And yeah, he left. Makes sense. I would have left too. We got 4 more minutes. I'm hungry as hell right now. Need some snacks. How'd you even get into competitive programming? Like so niche. It had to be a mouse slip, right? Like, why is this guy so bad? Yeah, yeah, minimal spanning tree. Like like you can use the DSU or prims. Probably some other stuff too. That's the only one I know. And there's like a minimum height tree. That one's pretty fun too. I'm just running my pawns up the board. He's gonna time out. He's taking way too much time on these moves. I had to close my union that I like solving problems. Yeah, that's how it usually goes, I'd imagine. I mean, I just take here, honestly. Am I cooked? I might be cooked. I don't know. I kind of figured he'd do that, but phew, pinned. Oh lord. Oh lord. Oh lord. Am I cooked? I just pinned myself. I can't do nothing. Fucked. Oh man. Insane way to lose a night. Pretty wild. Pretty wild. What do I get for not castling? Playing like a retard. What is happening right now? You're gonna time out. He's thought too hard. Even though he's winning, he's gonna lose the game. I don't think you can really do anything realistically. Yeah. All right. All right. What are we solving now? I'm kind of done off the decode a string. Does that even look fun? You're given an encoded string S, return as decoded string. An encoded string is K encoded string, and where the encoded string inside square brackets is being repeated exactly K times. Note that K is guaranteed to be a positive integer. You may assume that the string is always valid. There is no extra white spaces. Square brackets are well formed, etc. All right. If we could solve this, I'll take that too. So what does this mean? Why is there no explanation? Like, goddamn. Means A. B is being so B is being output 3 times. A is being output 2 times. Slightly confused. Okay, so there's two. So there's two of these, and then it goes A, and then B 3 times, then A, then B 3 times, then C. Okay. So how do we solve this? Let's look at the second example. AX B3. So every time we had a number, something special is gonna happen. So we could put AX B, and then we see 3. So you just repeat whatever's in the brackets. So were they nested? It gets a little bit more tricky. If you see a 2, see an A. Hmm. If we every time we see a letter, we like add everything inside the brackets into like a stack or something. So we add an A, and then we see a 3. So we say whatever's in the brackets, we add 3 times. So B B B. So maybe a for loop? I don't know. This is 2, so I'm thinking it should run 2 times. Alright, maybe we gotta draw it out. I'm thinking maybe have like a for loop. Every time you see a number, do a for loop of that many times, so like be 2, and then do everything inside the brackets. So you'll see A. Then you say a 3, so you do 3 B's. My question is, how do you know like when the bracket ends? So I'm guessing you see it 2. You see a bracket. I feel like you should go until the bracket closes. So like we start and we get maybe like a stack here. So like we add the open bracket. Obviously you have a for loop. So it's going to row 2 times. And we see A. So we had like res. And there's a 3B. So we get to the 3 and we go for loop. We get to the 3, the A, and then we say, hey, we found a 3 in another open bracket, so there'll be 2 open brackets. We see a B. It's gonna go 3 times, so it's gonna add B, B, B. We see a close bracket, so the close bracket would cancel out this bracket. We see another close bracket, it would cancel out this bracket, so we're done. So we get A, B, B, B. We literally just have to copy this how many ever times here. If that makes sense. For loop. Not sure. Not sure. Yeah, it would get A. Well, we should use a stack to close out the parentheses, though. I think that would make the most sense. Something like get it to hello, hello. Stack would have counter a 3. We don't append that. Do I want to do this right now? Do I really want to do this right now? I think the first example is the hardest example. This one's so much easier because it's just like A, B, and then you see a 2. So you just print whatever's inside of here 2 times, like CC. 3, so you put DD. 1, so you put an X. That makes so much sense. But once it's like nested, it makes nested so much harder. So instead of when you see a number, you just print the thing out a number amount of times. You have to evaluate this. Let's say we had a for loop and it's like a A3B. Tricky. Gotta come back to that. First linked list too. Design a circular queue. Pretty sure I saw this before. Damn, they really stepped up the difficulty on me. You're given energy right now, messenger K. There are two distinct indices I and J such that I is equal to J. Absolute value of I minus J equals K. Is K always positive? Okay, K is positive. It's absolute, so it doesn't really matter. Zero and three. Absolute difference between zero and three is three. Maybe we can have a map, like a map. One, it would have all the indices of the numbers, like 0, 3. Two would be 1. And 3 would be 2. And then for every key that has at least 2 elements. I feel like this map should be in order from like the smallest I to the greatest J. It could be over a million numbers. Over a million numbers. Then use 2 pointers to we could sort the arrays, but you have to have a way to keep their indices. Not sure. I think it just makes sense though. And just have a pointer in the front, a pointer in the back. Absolute value. I think we have one in the front, one in the back, because that'd be the biggest number. And depending on where I and J are, you move it. I think that makes sense. I'm gonna keep that idea. Or DERD. Or the map. Int and then a vector of ints. Call it dict. For what's up? Dict that nums of I. Push back. So she goes a map of everything. Right. If dict that values list value its size. Equals 1. Continue. Uh, fuck. 5. It's pretty nice. And then if res is less than k. If res is less than k, then we want to move. That means we need to go up. Sub, I'll sub if you do 10 push-ups. It's not the deal. You want 10 push-ups, you gotta like you can donate $1 or something. It's 5 push-ups for the sub. Can't really get any bigger because if we have left, if it's on the left-hand side, res is greater than K. Hmm. Bring the left pointer up. Both will technically make the number smaller. Both will technically make the number smaller. Hmm. So if we had like a list of numbers, 0, 1, 2, 3, 4. Okay. If you want K to get smaller, like right now, 0 and 4 adaptable difference is 4. If you want to get to 3, they move one of the pointers. I should know which one to move. I got no clue. I don't think this is the right approach for the 2-pointer solution. Maybe we both start them at like I and J. This would be 1. It's too small, so to get bigger, we I hope. Be 2 distinct elements. Two distinct elements. Not too sure. That's exactly what I was thinking about. What are they saying? If res is less than k for adjacent indices in your values vector, if the gap between two neighbors is greater than k, the gap between indices further apart will be greater than k2. My mouse just died. Think about it. How would it work here? So we'd have 1 would have indices 0 and 3. 2 would have. That's actually such a bad example. If we want to get to 4, what would we do? 0 and 1 is 1. I have to think about it. If res is less than k, like 0 is less than k, that means we want to go j plus plus. Like it's we're checking. It'll keep growing. If res is greater than, let's say we're at like 0 and 3, and we want to get to the, I don't know, 2 for a reason, wouldn't we just move L backwards. I backwards. The only problem is that we might go out of bounds. Why would we want to move L backwards though? I backwards. I starts at the beginning. Yeah, this is wrong. J minus minus. I have no clue. 2 pointers are death to me. What? That's insane. How does that even work? Yeah, I'm so I don't know. Like what? How does that even work?
Hey everyone, welcome back and let's write some more neat code today. So today let's solve the problem contains duplicate 2. We're given an integer array of nums and an integer k. We want to return true if there are two distinct indices I and j such that the two values at those indices are equal and the absolute value difference between those indices is less than or equal to k. Now the most important thing to recognize here is that
Wait, I'm retarded. Hold up. They said less than or equal to k? That changes everything. I thought I said equal to k. If it's less than or equal to k, literally, holy shit. Okay, pause. I read the question wrong. We just return true. And if res is greater than k, there's we need to make it smaller. Yeah, if res is greater than k, the only thing we could do is we gotta make it bigger. So j plus plus. I think that makes sense because we have zero. Think about it. Wait, actually, this makes so much sense. Think about it. 0 and 1 is difference is 1. K is 4. Return answer. Let's say k was, and then we say yeah. Then you just keep moving j up until either wow r plus plus because the first occurrence and the closest occurrence would be the smallest possible answer you can get. And if it's less than k, return true. And if it's greater, if res is still greater than k, we just need to go r plus plus. So we really just need to do with, well, r is less than value dot size, and long as you just put an ampersand, as long as r is less than size, yeah, and r is less than size. I think this makes so much sense. So it's less than or equal to return true. And if res is greater than, we just need to move r up one. Yeah. And return true? Something like this. Wait, no, I'm tripping. False. Let me double check my work. I think this makes sense though. We have a map. The value if the value of the vector is equal to one, then obviously just continue. Can't possibly be an answer. Left and right pointer. I is gonna be then just go r plus plus. This is gonna work. Oh, oh. What did we do wrong? Is that a for loop? Up here. In member function bool solution, there's no member name pushback. Did you mean oh typo? Yeah, that makes perfect sense. Let's go. Of course. How do we get the wrong answer? Less than or equal to k. So our dictionary should have had for one. It should have had 0, 2, and 3. The difference between 0 and 2 is 2, and then it goes up. It's less than or equal to k return. In this case, we would have got 0 and 2, so this would have been 2. 2 is greater than. Means res is greater than k. If res is greater than k, it means we make it smaller. Going r plus plus is not really going to help me. Yeah, okay, that makes more sense. Alright, I knew we weren't that fried. Oof. That took longer than expected though. I was not my happiest moment. The optimal solution. Don't really know. Been on live for 1 hour and 50 minutes. I'll take it. 124 problems. Not bad. Minimum size subarray. What is this? Never even solved this. Given an array of positive integers nums and a positive integer target, return the minimum length of a subarray whose sum is greater than or equal to target. There's no such subarray, return 0 instead. Alright, so given an array of positive integers nums and a positive integer target, return the minimum length of a subarray whose sum is greater than or equal to target. Is this like can't I just make a prefix sum? It's literally like if I made a prefix sum of this array, I'd get 2, 5, 6, 8. Wait, 5, 6, 7, 8, 12, and 3. Wait, no, what? 12 and then 15. And target is 7. So I'm going to say, what is the minimum where you can get 7? Did you get 7 here? I have an O of n squared solution, which is, I mean, if you figured out an O of n solution, try another. Oof, I have an O of n squared because I have the whole subarray, and then I'd have to do every single query again. I'm gonna try it. Let's brute force it for now. So int total vector of ends called prefix. That shit's O of n squared, bro. What's the O of n solution? Prefix that tells you like that tells you literally the sum of every subarray from there. Two. Let me say two. I'm gonna subarray it at two. Who cares? Prefix that pushback num. Uh, that's pretty good. And for int j, well, j is less than. It would go like 0 to 0. It'd be one element because it'd be yeah. Prefix at L minus one. Like that. At I minus one and j. And res greater than or equal to target return. What even return? Um, Like we'd find it here when L is at 0, 1, 2, 3, 4. It's at 5. 4 minus 5. So J minus I plus 1. So when J got the 5, so return 15. When J is at 4, it would return 8. 15 minus 8, 7. 7 is equal to target, so we do 5 minus 4 is 1. Yeah, it makes sense. This is definitely like kind of shitty. Compile error, what? Load. Pushback 0 for num and nums. Total plus equal num prefix dot pushback total. Let's just start off at 1. Start off at 2. Well, no. Start off at 1 as well, bro. Fuck it. It might be a 1 by like. I think, yeah, I figure it's gonna be a counting error now. So this would really be 6. This will be 5. Oh, it says the minimum. What the fuck? God damn it. This actually does work. The plus one's good. The minimum. I think I know. Ant. Ant equals the min of this and uh, max int and the min of this ant. The only issue now is if res equals max end, return 0. Alright, this will work. Max int is not a thing. Is this not a thing? Max int? Oh my god. I know I solved it like a retard, but like still. Is this not C++? The macro not defined include, oh, you gotta include the limit. What? Int ands. So what am I supposed to fucking do if I can't use? What's this restraint, bro? Dude, why doesn't this work? What the fuck? Common analog. Oh, it's int max. It's int max. Okay. There's no way this is gonna work. This is like the most retarded solution ever. This is gonna time out, most definitely. Yeah, TLE. I kind of figured. Can't. Take a quick break. Probably get my ass beaten chest real quick. Smooth operator. I'm on my 5 minute break, man. I'm on my 5 minute break. Can't do CPP forever. I bet he's definitely gonna take. I mean, there's a bug in my thumb. There's a happy face. Definitely a bug. That gonna do something. I cooked. Check. Boom. I'm an idiot. There's no way he's gonna checkmate me in 3 seconds, right? Get the fuck out of here. Draw, whatever. I'm hella consistent every day, all day. Alright, whatever. We just got like fried. Alright, back to the grind, boys. So you got a sub. I'm the most consistent YouTuber out there, bro. We don't play those games. We only go hard. Alright, our solution was shit. That's really the problem here. How do we make it O of n instead of O of big O of n squared? You know? It'd be beautiful if we knew that. I think I need a hint, bro. I think I need a hint. My solution way too slow. Please give hint. Roll the window until the sum is big enough, then shrink the window as much as possible. I think. So let's say we got our prefix sum. Wait, are we even using a prefix sum? My bad. Someone's texting me. All right, so if we have a left pointer at the 2 and we slide over it, this will be 5, 6, 8. Boom. So now we should shrink the window as much as possible. Oh, does that even make sense? How do you know it's not in the middle though? Okay. Forget the double for loop. I think the obvious answer is just like a slide over. As soon as we get to the 8, or anything that's above target, we'll save this as like 4 numbers, right? It's like 4. That's like it's saved. Now, how much should we delete? Right now, we can't delete anything because it would go under. So we go up here to 12. 12 is greater than 7. No shit, right? But that means there's 5 numbers we could remove. So in my head, I think like we remove the 2, and then we'd have 10 right here. For this would be 10. Can we still remove stuff? No, because we only have 3 spaces to remove. So we go to the 15. This is really 13. So we have 5 to remove. Is that how that works? Is this how this works? Is this even prefix sum? It is a prefix sum. We're making a project later, actually. But leetcode got an interview coming up. Gotta grind. Gotta grind. Kind of getting tired of leetcode though, bro. Like my brain's turned into mush. I do want to make a project, but I gotta keep the consistency on leetcode. Can't be fucking around. So my solution to use the double loop, but I should be sliding over. As soon as we go above the target, we'll start erasing stuff. Do I even need a prefix sum for that? All right, so we'll be at 12. 12 is greater than 7, so and let's say L is like right here, right? We'll remove at L. So this would be 10. 10 is still greater than 7. We can remove 3 more. But now leetcode just froze. What the? So now, why does it move everything? Now L is at the 5. We can't remove the 5 because it would be too low. I guess we go to the 15. Is that the answer? Go to the highest number and see how much we could remove? I don't know. Move 2 from 15, we'll get 13. Move 5 from 13, we get 8. Just not how that works. 12 from 15, we get 3. When you extend the subarray to the right, the sum only increases, obviously. When you shrink it from the left, the sum only decreases. Rethink the problem like this. Instead of for every I, try every j. Grow the window until the sum is big enough, then shrink it as much as possible. I think I made it too advanced by doing a prefix sum. I overcomplicated it. Do I even need the prefix sum? Yeah, you don't. I made that way too complicated. Whatever, we're starting from scratch. Sometimes it'd be like that. You gotta have the brute force solution first before you really get in there. All right, so let's say we have this number here, and we had a total. What did he say? What did they say? A left and a sum? So like sum is 0, left is 0, right, what do you want to have right as? We have a 0. So here the sum would be 2. Yeah, that's the minimum we could have. You just move right up. If it's less than target, we just move right up. Right will be 1. Sum goes up to 5. Still less than target. Right goes to 2. Sum goes up to 6. It's still less than our target of 7. So we add 2 more. Right goes up to index 3. Sum is at 8. 8 is actually greater than 7. But we can't remove terms of L because that's 2, and that'd get us down to 6, which is less than. So right goes up to 4. Wait, hold up. When right was at 3, we should have stored this in an answer. Like a res? What if equal like a right minus left plus 1. So 3 minus 0 plus 1 is equal to 4. So that'll be our answer right now, 4. We say we can move up one more time. Left plus 1. Well, this is the same thing. If I did left plus 1, this would be a 1. 3 plus 1 is 4. I just did the plus 1 over here. Yeah, that's like left plus 1. Unless you're saying you want to decrease the sum here. We go right plus 1 more. So instead of 8, we'd be at 12. 12 is greater than 7. Can we remove something? We can. We could remove the 2. So left plus 1, and we'd subtract whatever the left was at. So I'd go down to 10. Left is now at a 3. Yeah, left is at a 3. Think about this. Right now, this is greater than 10, and this is 4 minus 1 is 3 plus 1 is 4, which is the same as our current res, so there's nothing to really do there. But the interesting part is, left is at 1. 10 minus 3 is 7, right? 7 7 is equal to our target, which is equal to or greater than. So we should add that as a possible answer. So we'd look down here, we'd do like 4 minus 2 plus 1. That'd be 3. So our new lowest is 3. And right's at 4. So 0, 1, 2, 3, 4. Next, we add a 3. So 4 goes up to 5. 5, we add a 3 here. Wait, is that? Do we add a 3 here? 0, 1, 2. Yeah, it is a 10. Yeah, this makes sense. Sum is at 10. Obviously, 5 minus 2 is 3 plus 1 is 4. That's not less than 3, so we don't get go. Right is at the end of the loop, and we're greater than our target. So that means we can move nums at left. So nums at left is 1. 1 minus 9. 1 minus 10 is 9. And we check this. It's still greater than target. 5 minus 3 is 2, plus 1 is 3. We already have a 3, so we don't change anything. Now we have a 2. We can remove 2, so this would be 7. Yes, makes sense. I think we got it. 0, 1, 2, 3. Yep. Right here at 3. And now we check this. Wait, 0, 1, 2, 3. Yeah, we move left up, right, left up. 5 minus 4. 5 minus 4 plus 1 equals 2. And we just returned 2. That's the answer. All right, you said when the sum is greater than the target, decrease the sum by left head plus plus. Yeah, I think we're on the same page here. I'm just gonna comment this out for my notes, and then we could continue. I think we got it. So int sum 0, int left 0. Always, brother. We don't stop grinding. Int right 0. Perfect. And we need a while loop. We say while right is less than nums dot size. If right is less than nums dot size, that's beautiful. Sounds good to me. And Should I say and left is less than nums size? Could left ever? I guess if the target was like 0 or something. The target's at least 1. I feel like I don't need to do that. If it does, I'll change it. All right, now we just need some if conditions. So if nums of L, wait, no, chill. So now we do sum plus equal nums of R. Then the first iteration, now get us our 2. Now we say if sum is less than target R plus plus. Consider target 1 nums. Okay, let me think about this. Did we fuck up or something? Honestly, I don't know, man. We're just doing a 2-pointers. We gotta figure this out. We'll do the binary search next. So target 1, we'd go. All right, we'll get the 3 as our sum. So like the sum would be 3. 3 is greater than our target. Yeah, so if 3 is greater than our target, then we have to move left up. So what do we do if it's like it starts off too small? I think we just move both pointers up, right? Ideally, we'd want left and right to just be here. Still too small, just move them up again. Wait, no, if it's too big, my bad. I said too small. If it's too big, wait, hold up. This is greater than or equal to target. So this would be a possible answer. We'd save. Wait, the answer would just be 1, dude. Look, think about it. The sum would be 3. We'd have a length of 1, and that's greater than or equal to a target of 1. And we just return 1 because we'd calculate this as an answer. Works straight. Unless you could say something that's like would make that not true. And I think like I'm gonna say res, int res. How did Kazin like? I say, why do I keep calling him Kazin? This is like one of this guy I know. Karim, like, yeah, I was doing the last problem. I thought it was equal to. I had a similar problem one time. So if sum is less than target, just R plus plus, because we need to grow the target. So else if I don't think the only other option really is this greater than or equal to. So if it's less than target, else we should calculate the answer. So ants equals, it'll just be right. Yeah, I even called it R. I'm not doing that. Is the R minus left plus 1? That means if it's not less than, it's either bigger than or equal to. If it's equal to, do we really want to shrink it? I don't know. I mean, we'd eventually have to. Then sum minus equal nums of. Yeah, so if it's too big, we just do sum minus equal nums of L. Forgot some semicolons, and then L plus plus. Actually, a cool way to do it is just do L plus plus, because it'll add it and then do it. All right, does this reflect our plan? So if it's less than, we keep raising LR up. If it's greater than or equal to, then we want to shrink it because we need to find a new possible answer. So we move the left point and then move the left point up. Yep, and we just never compared res to the answer. So like res equals the min of ants and res. Only problem, I started res at 0, so maybe I need to start at int. Or is it max int? I think it's max int. That should be it. And then return if res equals max int. I do not need those. Turn 0. Because that means there's no way to make the subarray. And if that doesn't run, then just return res. Is this right? Okay. Max int, so we have a big number. Well, r is less than nums of size, so until the right pointer goes all the way to the end of the array, sum equals nums of r. If the sum is less than the target, then just move right up. Yeah, I think that makes sense. We move the right pointer up. And then the next iteration, we'll add it again. Yep. Else. So if it's not less than, it's either equal to or greater than, which is both possible answers. So we calculate the size of the current subarray. And we're going to shrink it from here. So we shrink one, and then we compare the answer. I think, I pray. I know it's not max int max. Int. How long have I been here? 2 hours and 39 minutes, Lord. I need to go soon. I need to solve, I just want to solve one then. Compile error? What the fuck? Come on, give me this, give me my glory. Okay, a bunch of semicolon errors. Need to really proofread. Runtime error? Overflow. L must have went over. What the fuck? Okay. Yeah, fuck this shit. I don't know, man. Yo, Karim, bruh. What am I doing wrong? I literally got the answer when I did the super brute force way. Like the sum would be 1. That's less than, and the target is what? 4. T equals 4. 1 is obviously less than 4. So we go R plus plus. It goes again. We say sum plus equal nums of R. So that would be 5. Right? 5. 5 is greater than 4. So ants should be. You don't understand what I wrote? You sliding. I thought I was sliding the window. I don't know. All right, my idea. So once we get 5, it should have been here. You need to loop I in range n, and inside you update using j. You need to loop from I in range n, and inside you update j using a while loop. Oh, brother. I like my TLE answer now. I use a nested for loop. I feel like I'm close, though. Is this like totally wrong? Because I got 5. 5 would have went 1 minus 0 is 1, plus 1 is 2. Output 0. That should have been 2. Wait, why is it not 2? How does that even make sense? Res is 0. Sum is 0. We add 1. It's less than target, so we say R plus plus. And now we add nums of R, which would be the 4. So this should have been 5. Sum should have been 5 right there. 5 is not less than target, so it should have computed the answer. Right is at index 1, left is at index 0. 1 minus 0 is 1, plus 1 is 2. And then res is the minimum between ants and res. Res is literally fucking int max, a maximum integer. How in God's green earth did this not reassign? What? See out some new line. All right, it literally hit 5. I'm clearly not calculating something right. The sum hit 5. That literally 5 is greater than goddamn 4. What did I do wrong? So if sum is equal to 5, that means it would have went here. Ants is equal to. I gotta see out ants too. Maybe don't end the line here and just have like plus. 5. It's literally 2. Yo, you have to be out your damn mind. It is 5 and 2. That makes sense because 1 plus 4 is 2. So why would it return 0? Do sum plus equal nums of r inside the if. Is that it? Yeah, it has to be something small like that. There's no way. Whatever, still got it wrong. It's more fucked up now. Because before it said 5 and 2. Now it says 5 and 3. 3 does not look right at all. If the sum equals the target, then update the result. That's what I did here. Because if it's like, 'cause I have this conditions less than, so if it's either greater than or equal to, it should run this. Now it outputted 2. I just need to get rid of this 1. It's literally like that has to be the answer. Okay, I literally only got the 1 right. Now the counting is just off. What did I... Dude, it's like it's close. I got these 2 right. What's going on here? Output 3, expected 2. Okay. Obviously the last 2 would be the answer, so... I got a 7. And it says there's only 3 numbers. I wish I knew what numbers added up to that. Let's think about it. How would it get that? How would it get to the 8 first? So it would have added like... What if the sum is greater than the target then? If it's greater than the target, then we calculate one of the answers and then we try to remove as many numbers as possible. Yeah, I had that before. I know. I had L plus 1 plus 1. I had this. But it... Okay. Alright. I did, but I got this one wrong. This should not be 2, bro. On everything I love, this should not be a 3, I mean. Because how would the size be 3? It's like 2 minus 0 plus 1. It's how I'm doing the plus plus. I think it's the same exact shit. Alright, I need to really trace this. Why would I get 5 and 3? So we add the 1. So sum would be 1. 1 is less than 4. So we add 0. So it starts off at 0. 0 is less than 4, so we add the 1. Next loop. 1 is less than 4, so we add the 4. So now the sum should be 5. Next loop, we get the 5. Oh. I incremented. I did R plus plus. So, because that's the next number I want to add. But in the next loop, yeah, it's not in the right position. It should be r minus 1. Like, the r should not be in the 2 position. It should be in the 1 position right now. What? I don't know. This looks retarded. That looks retarded. I don't think that makes. Yeah, it only fixes that problem. I tried. Please give a hint. Free my soul of this torment. All right, so what you did, right? 2 pointers, running sum. That was L plus R. Wait. R minus L plus 1. And you said that was R minus L plus 1. What do you mean? Yeah, and I added that. I don't think this works. I don't think that makes sense. Let's see, what did ChatGPT say? The real core issue here is our while loop. Think carefully about this question. What happens if R reaches the end, but the sum is still greater than or equal to the target? Oh. Right control expanding, left control shrinking. Right. Okay. So we have and. I think we should have said or. It's tweaking. Goddamn. Now we just getting overflow errors. Bro, what the fuck? He has 2 while loops. Oh my god. And then do I just try this? They had basically the same thing as this, but it's a fucking wild loop, bro. I'm so tired of this shit. So while the right pointer is less than the size of the array, okay. And while sum is greater than target, update your answer. Okay. That's kind of what I did. Except they just put. Can you not move a line up? Bro, what the goddamn hell? Yeah, oh yeah, it's just some bullshit. Grade A bullshit, bro. Alright, so they fucking did that. Does this even work, man? Well, sum is less than target. Let me get out of these fucking print statements. See what happened in this test case here. 144. Okay, yeah, so it's already there. So they both start at 0 while R is less than nums dot size. Some at nums are, so sum will be 1. R plus plus, so now it's at the 4. While sum is greater than or equal to. Greater than or equal to target? The sum is greater than the target. I'm starting, my brain's starting to get fried. I'm fucking getting off after this. If the sum is greater than the target, that means we're gonna save our answer and shrink. So our answer would just be the right pointer minus the left pointer plus 1. So that gives us our window. The sum, we need to subtract the left pointer and move it up because we're getting rid of a number. And res is going to equal this. Is that literally it? Was it just a structural thing? No way. Invalid. What? The fuck are you on about? Invalid test case? I don't even know what I did. Is there a way to reset the test cases? Whatever. Bro, nah, I can't do this shit, bro. Fucking bullshit. Maybe another day. Maybe another year. Output 3, expected 2. That's the answer, bro. But jump off a bridge. That's the answer, bro. Oh my god. Does that even count, bro? Does that even count? That was terrible. It kind of made sense to have a while loop to shrink, because, like, what if you get a really big number? You could shrink as much as possible in one loop. Alright, you know? I definitely gotta come back and solve that again. I'll probably do it on leetcode. Like, I didn't, yeah, that's kind of cheating. I'll come back and solve it. Yeah, it wasn't like, I guess the main takeaway, you gotta think about what we learned. Our other submission timed out because we like literally created a prefix sum and then used a nested for loop. We got to that other solution, it was kind of buggy because I didn't think to use a while loop to delete elements. It makes more sense. I used the if statement because I only could delete one element at a time. So I guess, and for future reference, make sure you think about that. What do we even do now? Not sure. Yeah, is there any content you guys want to see? Like, I was thinking about making some like YouTube videos. You guys want some leetcode tutorials? I swear they won't be as like washed as what you just watched. It'll be like prepped, but whew. Or should we build a project? What do you guys think? Why I type like a grandma? Anyway, I think that was a good leak code session, boys. I appreciate everyone that popped out to the stream. I'll probably be on later.